Hey, I'm Nick from the Container Tools team at Google, and today I want to talk to you about one of our newest and most exciting tools, Scaffold. Scaffold is a tool that's designed to make local Kubernetes development easy. It watches your local application directories for changes and can automatically build, push, and deploy your application images to any local or remote Kubernetes cluster, letting you focus on developing your application. Let's take a look at how to get Scaffold running on your application. Scaffold runs as a binary on your local machine, so installing it is as easy as downloading the latest release from the Google Container Tools GitHub page. Alternatively, you can build Scaffold straight from source. Scaffold uses YAML configuration to describe how your application should be built and deployed. You can specify one or more images for Scaffold to build, which Scaffold will tag and push to any valid Docker image repository. These continuously built images will be injected into your Kubernetes manifest and used to deploy new changes to your cluster on every code change. Let's walk through an example to demonstrate a typical Scaffold workflow. Here we have a simple Go Hello World application, which just prints Hello World in a loop forever. We have a Docker file that builds a binary from the source file and puts it into a container, and a Kubernetes manifest that creates a pod from this container image. Scaffold has a built-in command, scaffold init, that will generate a Scaffold YAML for your code base containing default values to get Scaffold running. Let's run it on the code that we have here. You can see our generated Scaffold YAML has one build artifact pointing to our Docker file that builds the image and pushes it to our project's registry. This image is tagged with the Git tagging strategy, which uses the latest commit hash as an image tag, though there are several other tagging strategies available. Scaffold also defaults to using the kubectl deployer that deploys from our Kubernetes manifest to our existing cluster, though there are several other deployment strategies available as well. As we run Scaffold dev, you can see Scaffold immediately builds the artifact we specified and pushes it to the target registry. It then creates a pod in our cluster using the image we just pushed. By default, Scaffold streams the logs from the pods it creates, so looking at these now, we can see Hello World being logged like we'd expect. One of Scaffold's most exciting features is its File Watcher, which watches for changes to one or more local directories on your file system in real time. When Scaffold sees any changes to your code, it will build a new image from source and deploy it to your Kubernetes cluster. Let's change our print statement up and watch how Scaffold reacts. As I change this string to Hello Scaffold, we can immediately see Scaffold recognizes that our source file has changed and retriggers a build and deploy. Watching the logs, we can see them switch over in real time to our new print statement as the new pod is created. Let's take a look at a more complex example to see how Scaffold works with more realistic workflows. Here we have an application with two services, a web server and an application server. These services can be built and deployed independently of each other, and Scaffold is smart enough to understand that. Let's go through the same flow we did with the Hello World example here to see what it looks like. Running Scaffold init again, this time we're prompted for which Docker file builds each image, since there's no way for Scaffold to know that beforehand. In our generated Scaffold YAML, we can see that a build artifact is specified for each service's source code directory, and Scaffold will put a separate file watcher on each of these directories. This means that when files change in one directory but not the other, only the container corresponding to the modified directory will be rebuilt. Scaffold dev builds and deploys both parts of the application as we expect, and in the logs, we can see both services are ready in our Kubernetes cluster. Now, if I go make a change in the web server, we can see Scaffold picks up the change and only rebuilds that container. Scaffold's deployer then only updates the deployment associated with the newly built artifact, and we can see this reflected in the deploy logs. This means your dev cycles are never bottlenecked by parts of your application that you're not working on. These services don't necessarily need to live in the same repository. As long as your Scaffold YAML points to valid workspaces on your local file system, you can use any number of different repositories in a Scaffold workflow, making it an awesome tool for development on microservice-based applications. Scaffold can help speed up any Kubernetes development workflow by getting ops out of your way, allowing you to focus solely on application development. You can find these examples and more in the Scaffold GitHub repository, linked in the description of this video. Contributions to Scaffold are always welcome. If you'd like to learn more about contributing, check out the contributing guidelines in our GitHub repository. Go try it out for yourself and let us know what you think. Happy scaffolding!